might as well, because, yeah, there's... I want to angle the field more to... I don't know if it's come up yet. Right, this new design. Oh, it's blanking out on me again. Right, there's some concentrics underneath here, right? Right, this is one of my concentric bobbins that holds the magnets. Now, it's actually... oh, which one's this one? Hang on. Get mixed up. Which is which? Oh, that's the 3... Oh, no, it isn't. Hang on. Where's the 3 one? Just a minute. Measure it. I can't remember which is which now. 6.1, 2, 4, yeah, that's the 3 one. That's the bigger one that I'm planning on I'm going to be using, but I have to make this holder bigger because it won't accommodate this thing. Because I've got smaller ones. Let's see, where is it? The smaller ones are over here. That was the 4 one I tried and it wasn't very good because the magnets were too deep. And that one didn't work so well. This is the one I've been using, this concentric here, with 2 magnets. Yeah, that's 4.1 millimeters, so that's the one. I've been using that one. My previous design was this one. I've got ferrite cores in here. This was originally with 2 bobbins, and I had concentrics in there. And it didn't work so well. It didn't work so well until I put the actuators on the top instead of in the middle. The middle actuation didn't work very well. So this one is the new one with the actuators on top. I've extended this now to that, and I've got to wind coils for this. So as I go back, see that's the previous one. That's the one I'm using right now. That's the one I was using before. So this is the new design. It gives me more space because I'm using the 16mm Alnico magnets in these shuttle bobbins, and they act as a latch. To actually turn them, to flip the polarity though, it requires a lot more energy. So unlike ferrite, which is very passive and the flux field moves very easily through ferrite, the Alnicos act like a resistor. They behave a bit like a resistor, a high value resistor, and you've got to put a lot of power through them. I'm talking in terms of the magnetic field. You've got to put a big jolt of energy through them to get the field to flip over. But once it flips over, it stays flipped over until you reverse it, and it works better with longer magnets, because the previous one, I'm using an Alnico, a rectangular, that's the red thing in the middle there, right? The red thing in this here is an Alnico magnet, and it runs all the way through these 2 bobbins. and just part of it in the middle, which I was centre tapping a magnetic field onto it. Excuse me if I don't talk too much, because it's sort of in my throat. So now, if you look, let me just unlock this, because I can't really show you properly. Right, if I hide for a minute, unlock, hide that a minute. Now, I have a concentric magnet holder in the centre there, and I tested this first, and it turns out that this concentric doesn't work very well in the middle pillar at all. It works a lot better when the concentrics are actually on the end bobbins. It works a lot better. It's more balanced. So I did away with that concentric in the middle pillars. I had 2 bobbins on the ends. I took 2 of the bobbins out, 1 off each end, and because I did that, the spacing was all wrong on the middle bobbin, and the ferrite wasn't meeting up with the actuation thing. So I had a problem which I had to deal with, and the way I dealt with that was I simply used 1 bobbin on each end, and that seemed to work. And 1 bobbin on each end with concentrics on the tops and bottoms of them, and I basically did away with the middle bobbin. The middle bobbin wasn't a coil, it was just a magnet holder. It was to hold the magnets, really, because there isn't any field much generated in the middle. So I'll just undo that. Relock that again. I locked it so I didn't mess with it. Have a look. Oh, hey, Chuff. I don't know if you're watching, Chuff, I don't know. Sorry, I sound a bit rough. It's this cold. I've been down with it for 2 weeks. Anyway, I've already printed out these new bobbins, right? I'm just going to wind them, but I'm not going to wind them just yet because I want to make some changes a bit more to the bobbin holders. That's these things. Hang on, these things are what hold the bobbins together and hold everything in place. And I need to widen the holes up in the middle, and to do that I'm going to have to expand this thing a bit, because I seem to be, every time I make a change I'm doing a small test, and then I'm having to make another change, and I'm just wasting plastic, you know what I mean? So I've already determined that the concentrics, which are these things here, these will hold the magnets in, and I want to do offsets on there as well. At the moment, the magnets are, the yellow ones that are colour-coded yellow are actually lower down, sorry, higher up. So those magnets are actually a bit higher than the other 4 magnets. So that created an offset. Ideally I want to have the magnets at an angle so I can face the flux field directly towards one side, so it's more focused towards the coil on the opposite side, so that when I subtract 3 of the magnetic fields, the other 3 are more focused towards the coil. But I haven't figured out how to do that yet. It will mean making some distortions on the actual bobbin, on the holders. But I thought, well, rather than doing that, I'll just go for the bigger one first, because that will automatically give me a much bigger magnetic field. And this is a deeper holder, it's got it's much deeper, but it needs to be wider for the other concentric magnet holders, it needs to be a lot bigger, so I've got to expand. Actually, I think what I'll probably do, what I'll do is I'll make a copy of this one. I'll just alter this one instead of altering all these two, because it's sort of messy. I can see what I'm doing, you see. So if I copy that one, right. Oops, what have I done? I've just deleted something. Oh, no I didn't. I want plus, I want copy. Right, I've got two of those now. So I need to make that unique. Otherwise I'm going to change it, the others change as well. So what I'm going to do is I'm going to expand this actually, so I can make bigger holes, because it's got to hold concentrics in place. But you know, I haven't given up. I've been working on this still for the last couple of years or so, but I just haven't been in chat. I've still been focusing on it. So if I edit this one, I need to expand this out more, so I don't know if my stream's working because I'm not monitoring it, because I'll check anyway. I don't like going live much because the audio sucks on the live stream. I keep getting with YouTube complaints I've got bad video settings as well. It seems to be working. So let me just check this. I need to make some calculations with these. I'm just going to measure this thing with my calipers actually. So the existing ones are about 20 millimeters wide. I'll bring my calculator back up. So I need to remember that measurement, because I need to do something else first, because I'm going to lose that setting. I need to remove 1.2 millimeters from. Just get out of this a minute. From the height of that one. It's a bit too tall. Right. Right. 1.2. Alright, that's a bit thinner. Oh, right, I'm going to have to bring them down as well. 1.2. I've got to do all these flipping things. The reason for doing that is because my ferrites aren't quite long enough. Some of my ferrites are a little bit too short to go all the way through the plastic. And I was 1.2 millimeters short. I'm trying to maximise my use of the materials I've got. Because what I do is I cut these ferrites in half, and I've got a piece of ferrite for the bobbin. I've got a piece left over, and the pieces that are left over are going to be used for the concentrics, you see. Then I don't waste anything. And that one, I'll just go to the surface of that one, it'll be the same. Right, I think I've got it now. I had to make sure I did this first because I forget. That's 1.1 millimeters. unfold. No, that's, I think I've got them all. Yeah. I now sorted that out because that had to be fixed. Come on, computer. That's the one. Right, I forget that now. I've done it now. I need to. I've got to expand these holders because they're going to hold everything in place. You see, and oh yeah, that's what I was doing. Measurements for the. I've done that now, so I can wipe it. Okay, so the new one is the new 6 is 27 millimeters. So 27, and the previous one is minus 18.8 more or less. So divide by 2, 4.1. So I need to increase these walls by 4.1 millimeters on each side. 4.1 also on the ends. 4.1. Well, yeah, that'll be fine because the middle there's room in the middle for the overspill of the extra thingy, but so what I'm going to be doing is making these holes a little bit bigger, and so what I'll go to do here is seal that up like that. Actually, I probably need to go further back. Go up to here. Right, I've got to make the. This is where it gets fun. Just I'll do this one as well. I don't want the middle part doing. So this half circle-ish thingy. Alright, I've got to get that dimension sorted out. Right, 27.23. 27.24, I'll round the number off a bit, divide by 2, 13.62, so basically I want 13.62. Right, and I'll go trim this out. I'll do this other one as well, if I can get the middle. Where's the middle? Where are we at? .62. I've got to make modifications to this thing to hold everything so it doesn't fly all over the place when I'm driving the damn thing. I need to get rid of that. And this middle bit, because this is phantom, and this middle bit is a phantom. I just filled it so I could get my centre, you know. I need to get rid of this as well. Right, so when I push this down, I should have my, it's working, my new thing for the cause, so I've got on to the same level as that. Oops, I've gone a bit too far because I've got an overlap there. Undo that a minute. I'll come down. I don't want to go too far. I'll go down 11.4. I'll take this one down. 11.4. Right, okay, there we go. I've got my new hollowed out sections which hold the actuators. That was quick and easy, wasn't it? Now, because the actuators are sitting in there, they're going to be 9mm, so 9mm from the bottom, that's good enough. Well, I've got about 11.4mm, so I'm going to stick that out a little bit because I want a little bit more room there to, no actually I don't need to do it because the bobbins are smaller. Yeah, so that's going to be fine as it is. I'll probably have to put some collars on those bobbins to hold them central, or I'll just stick them with glue or something. But at least I've got my new holder designed. And by the way, I'm actually printing at 0.2mm printer, 3D printer resolution now. I never have to calibrate the printer anymore, ever since I sorted out a bunch of issues with it, and I haven't calibrated the printer for weeks actually, and every time I print it comes out great. So I've sorted out some issues I had with the Z-axis going out of alignment. The right hand Z-axis motor used to move faster than the left hand Z-axis motor. I sorted that out by reducing the acceleration speed on the Z-axis so that both motors accelerate at 20% instead of 100 or something. Oh, what was it set to anyway? It was at 100 or something, and I reduced it down to 20 or 30, was it? Anyway, I've not had to calibrate it since then, and I'm just amazed actually how well it's working now, which is really good. Alright, so that's the new extended holder which I'm going to need to hold everything in place when it's activated. So if I just export that, so I'm going to call it, where's the other folder name? I called it hold along, so I'm going to call it hold along so I'll call it C63 C6 by 3mm. I'll know which one's that one is, because the others are different. I've got different holder sizes. So set that. Right, I'm just going to check it for errors, because there might be something. No, perfect, no errors. So we've got big hollowed out sections now, which will hold the larger C6s, magnet holders. Right. So I'm just going to open that and slice that ready, and then I'll print them up later. Then I can start building this new version. So I'm really eager to try these out with extra magnets in. Compare it. So I need that wants to be flipped actually, or maybe no. Actually, no. I won't flip it this time, because there's going to be damn sight more support material on this side now than there is on the other side. So I think I'll leave it that way. Yeah, I will. Alright, I need 2 of those. I'll probably print these out tomorrow though, because I'm a bit shattered actually. I've been up a long time. But it's nearly sliced. So it drags on a bit sometimes when you print it, especially when I print stuff at 0.2mm resolution. It takes forever to print stuff. It's probably going to take about 6 hours to print these 2 things, and they're not that big really. See how long it's going to take. Yeah, 6 hours 42 minutes. I don't mind, it looks really good actually. The resolution's really good on it. Right, I'll just rename that, because I don't like +1 on the end, so I'm going to put 2 times. Right, that's ready to print. Yeah, I've got support material underneath. It won't be as bad as what it would have been if I turned it over though. It's a shame though, because the bottom is really the top, and it would have been better for that to look nicer. But well, I'm just trying to save plastic, you know. So we'll look at how much support material there is underneath. Not too bad, I can chisel that out. Well, I found using my chisel just gently is a lot easier than using a knife sometimes, because the knife does the tendency to break blades and stuff, you know. Right, so that's that sorted. Just going to synchronize my hacksaw journey. Yeah, it's fine. This is late. Oh, Chuff answers me. Right, well, all I can... Oh, shit, I wish it wouldn't do that. It scares me. It keeps going blank. I think it's my browser's going to crash. What I was going to say about this, right, is... I've had some really strange things going on with this thing, I tell you. I don't quite fully understand it, but a lot of people who add magnets to a transformer seem to think that it gives them a gain, but when I've done tests with a transformer using a ferrite core, you know, a ring, or a standard transformer, the changes I've seen are more to do with inductance and detuning the transformer or tuning the transformer. Because you have to remember, the only way to test this properly is to use the demagnetized magnet to test it for inductance, reactance, and then use a magnet that's magnetized and then test it. So the way I've been doing that, because I'm using Alnico magnets, you can actually magnetize them and you can demagnetize them. And when they're in a demagnetized state, you can use them inert, because they don't have a magnetic field on them, and you can test to see the difference between an Alnico that's not magnetized and an Alnico that is magnetized. And I found out that in a lot of situations, it's not the magnetic field of the magnet that's changing the performance of the transformer, it's simply the fact that it's acting as an inductor. But if you get the magnets set just right, if you get the magnets in the right position and balanced, then it does work the way my theory says it should work. That is let me just synchronize this a minute before I forget. I'm just sending this across to my SD card. You see, what happens is let me just go over there again and show you what I mean. Right. Now, you've got 6 magnets in these holes, right? And we're only interested in the field on the inside, not the outside. So, this top one, say that was south, pointing inwards. And the next one to it is north, pointing inwards. Then the next one to it is south, pointing inwards again. And then north, south, north, all the way round. Now, what happens is, when you apply a magnetic field, an actuation, when you energize a magnetic field on the center, let's say it's south, right? What that does is that subtracts all of the north-facing inner facing magnets. It subtracts all of those north fields up towards the actuation field, right? When you subtract that, you allow the other fields to deflect down. And the other fields are deflected down towards the collection transformer, the collection secondary coil. Because we're subtracting something, the lens effect doesn't come into play. it doesn't come into play immediately, because the lens effect, first of all, has to overcome a missing field which has already been subtracted from on this side, and it can't quite reach that field. It can only reach the field of the polarization of the magnets which are already being deflected down, because there's nothing to hold those fields that are coming down unless you overcome those fields first. So you've got to overcome those fields first in order to pull the other field back down that's been subtracted by the energizing actuation. This is why it overcomes a lot of the lens effects. And I've been working on this for the last 3 years now, and I've seen some positive effects, but the only problem I've had is cutting through the flux lines, because the flux lines tend to be very low lying, they're very low down, and you've got to get them out. You've got to drive them in such a way that they actually interact with the coil. And my coils in the past and the previous builds were too big, and the iron was reacting too slowly. And that's what I've discovered is the reason my previous builds didn't work properly is because the iron, I was using steel iron, the iron was reacting too slowly, and it wasn't able to transmit the flux very well. And strangely enough, by using ferrite, which is actually seems to be less magnetic than steel or iron, works better than the iron did. So the ferrite's actually better. So this is what I'm using now. I'm using some ferrites which I've had to cut in my drill, and so I've been testing out my ideas on ferrite instead, and it's been a lot more positive than what I had with the steel. The designs are basically the same, similar, because where's my other build? Oh, the one with the steel laminations is over here, look, right? It's right over here. Now my laminations are under this slot. I'm going to hide that. Right, there's my laminations that they're cut by laser. They're in this new design I did. But I haven't built this one yet. I've printed the parts out, but I haven't built it. You can ignore these cross beams. Hide that. You can ignore that because I've already determined that that's not going to work. But the centre pillar will work if it's connected to the concentric magnetic fields, but they'll have to be on the ends instead, so I've abandoned this design for now because I've already discovered what I need to do with the smaller version, so it'll be the same for the larger version. So yeah, there's going to be a lot of changes I need to do to this one with the steel, and I don't think it'll work as well anyway because the steel just reacts too slowly. It's not soft enough iron. And that's probably the reason why the design ferrite core is based on iron powder, because it seems to work better when it's crystallised. And I'll just undo all what I've just done there. Right, so it was good to go down to this small scale because it saved me a lot of money, because I'm not going to get any more steel cut anyway. I'm just going to cut some ferrite, and it's not too bad either with the diamond cutting wheels. It cuts through ferrite like butter anyway. Alnico takes 50 times longer to cut than ferrite. I could cut a ferrite slug in about 3-4 minutes, and it was taking me like 2 to 3 hours to cut through a small 5mm diameter piece of Alnico. That proves how much harder that stuff is. It's really hard stuff, and it was knackering up all my it was wearing out all my diamond cutting wheels. The Alnico was, but the ferrite, I can cut loads of ferrite with the same diamond wheels, and they last forever. So ferrite is a lot softer. than Alnico. Now, Alnico's got a soft magnetic structure, but it's very hard material. So it gets a bit confusing when people tell you that, I think it was, what's his name? What's his name? Oh God, I can't think now. Anyway, he was saying it's a relatively soft magnetic material. Well, it is soft magnetic material, but it's a hard physical material. Very, very hard. When he talks about soft magnetic material, he means that it can be moved. It can be shaped more easily than a neodymium magnet can be. A neodymium is permanent once it's done, because it's cured under high temperatures. Apparently, the magnetic field is set under high temperatures. That's why you can't heat them. You can't heat up neodymiums. I think it's above 80 Celsius or something. And because I think around about 80 to 90 Celsius, it loses its magnetic properties. But Alnico, you can take it up to 400 degrees Celsius and it'll still maintain its properties. That's the difference. Alnico can withstand much higher temperatures, and it's more suitable for driving with higher currents and things like that, higher temperatures. But unfortunately it has drawbacks in the fact that if you put a neodymium near it, it will lose its magnetic properties if it's reverse biased. But that's an advantage in a lot of situations as well. So, yeah. I better check that chat now. Well, it's still working at the moment. But I can't put my mouse over some of these things because it just blanks out on me. It's just annoying. Right, that's done, so right, so these things, it's these bigger ones here. Right, this thing here should fit in there. Oh, I hope it will. Have I got the right one? There's something wrong here. I know, that's the wrong one. No, yeah, that's the wrong one. Undo that move, because that's the wrong one. It's this one. Yeah, this is the one that should fit in here. That's the one. Right, as you can see, I think I've got my measurements about right. I think I need to, yeah, that's alright, that's going to fit snug. And, because there's 3 of those magnets in each one of these slots, so it should be 6mm that. Yeah, 6.1. So that's the right one. I need 2 of these, so hang on. Right, so those actuators sit like that. Good thing I grouped it, otherwise it would have melded to it. So I can select that, make a new group. So that's all one group now. So those are going to be sitting in there like that, you see. Then the actuation coils are on top, which is actually on the bottom on here. So the actuation coils are going to sit on top of here, and they're going to pulse these the concentrics. The alnicos are pulsing these concentrics, and then the coils underneath, the secondary coils, collector coils underneath, between these and another group. So there's actually two sets of these. So I don't have to draw it out again because you'll see it when I build it anyway. I don't think I really need this hole in the middle anymore, but I'm going to leave it anyway, just in case. So I think that's about it. My voice is getting sore because of this cold, so I'm gonna end the stream in a sec. But you see the idea. I better say this actually. Right. So is that? I think I'll lock that for now. Just prevents me accidentally doing anything to it. So this is the next phase anyway. I've just got to get them coils wound and get those new holders printed out. I'll do that tomorrow. And going to be doing some more testing during the week using these 16mm long alnicos instead of the current solid 20mm alnico rectangular, which has got two actuator coils on each end, which wasn't really a good idea. It doesn't really help. It's less efficient. These will be much better because I did these with I explained something about this previously. What I did was I had 3 alnico magnets in each bobbin. Right. And I came to the conclusion after doing a lot of testing that using 3 is not practical because you need 3 times as much power to flip 3 alnicos as you do 1. And 3, I doubt if I could even saturate 1 alnico, 60mm alnico. I can't even oversaturate one of them. Because when you put power in to flip them, I'm not flipping them 100% anyway. They're only being flipped something like 3 or 4%. They're changing polarity about 3 or 4%. They're not changing polarity 100% because I'm not putting enough power in. So using 3 of them is really stupid, because that's like trying to lift 3 elephants all at once with one hand when you only need to move 1 elephant at a time. You know what I mean? It's just dumb. So I decided to go with 1 alnico in each side because that's the bare minimum, and each alnico is quite capable of pulling that flux around the circuit. Because what happens is when these 2 alnicos on each side flip over, they change the direction of magnetic flux flow from this direction, going all the way around anti-clockwise, and when they flip the other way, the flux goes clockwise, right? So once they're flipped over, they'll stay in that state until flipped back again. Now, using surplus amounts of energy to flip 3 alnicos is a waste of bloody time, because that's like using a 60-metre sewer pipe, a 60-metre wide pipe to fill a glass of water with. I mean, it's ridiculous. It's not needed. You get what I'm saying? So I really don't need a big thick pipe like that. I just want a small pipe to just change the flux flow. Anyway, that's it for now. Yeah, what's happened to it? Anyway, that's it for now.